UV light can further be divided into UVA, UVB, and UVC. UVA has the longest wavelength, while UVC has the shortest wavelength. UVA can promote melanin and protect the skin. And UVB can cause photochemical smog, but it can also have an anti-rickets effect. Rickets is a disease caused by lack of vitamin D and calcium. So people with rickets often have weak and soft bones. UVC has the shortest wavelength and can be used to kill bacteria. Visible light wavelength is between 400 to 760 nanometers. So you can see violet to red. Infrared has local thermal effects. It can increase blood temperature and dilate blood vessels. It can also promote metabolism and cell proliferation. So the right dose of UV light from solar radiation can have beneficial effects. But if overdosed, you can have harmful effects. Beneficial effects include skin pigmentation, anti-rickets, and sterilization, and others. While harmful effects include erythema, skin cancer, and others. So what about infrared? The right amount of dose of infrared can have beneficial effect. For example, it can provide heat, and it can use to dilate blood vessels. It can also promote metabolism and cell proliferation, like we just talked about. And it has anti-inflammatory effects and can be used to treat chronic skin diseases and frostbite. If you have too much infrared, or if you overdose infrared, it can have harmful effects. For example, it can cause heat damage to skin tissues, skin can burn, and you may also develop cataract. So what about visible light? Of course, we need visible lights to see. The second one here is a circadian clock. Circadian clock used to be a very hot topic several years ago. So what this means is that your behavior or your biology will change in a day-to-night cycle. So imagine your genes, some of your genes are turned on during the day but turned off during the night. But some other genes are turned on during the night and turned off during the day. Meteorological factors include air temperature, humidity, airflow, and atmospheric pressure. Next, we'll talk about air ions. So light ions are neutral gas molecules, and heavy ions are dust, smoke, and suspension water particles. So the ratio of heavy ions to light ions, if it's less than 50, means the air is clean. Air and ion can improve the function of the cerebral cortex, boost morale, and reduce fatigue and improve work efficiency. It can also improve sleep and increase appetite and excitement. So air and ion is considered good for us. This is a table of air and ion concentration of different air environmental conditions. Suffice to say, the most air and ion concentration, or the highest air and ion concentration, will be at the countryside, like the beaches, forests, and waterfalls. And the lowest air and ion concentration will be close to the cities, like the city office or the street. Next, we'll be talking about sources and types of air pollution. We'll also be talking about factors that influence the concentration of pollutants in the atmosphere. We have also talked about sources of air pollution, including natural pollution or man-made pollution. Natural pollution includes volcanic eruption, forest fire, and man-made pollution includes industrial production, pollution that are caused by everyday lives, and other types of pollution. Man-made sources of air pollution can come from industrial and agricultural production. This is caused by the emissions of industrial processes. Another major air pollution can come from fuel combustion. This is a major source of air pollution if you use coal and oil. Another source of air pollution can come from everyday lives, such as stoves and heating boilers. This is because stoves use coal or liquefied petroleum or natural gas. And coal especially is an important source of neighborhood air pollution. Another major types of air pollution can come from transportation. Transportation refers to cars, planes, trains, ships, tractors, motorcycles, and other motorized vehicles. And these transportation vehicles can emit a lot of pollutants into the air. Types of air pollutants include gaseous pollutant and particulate pollutants. These four kinds are the most common gaseous pollutants. The first one is nitrogen-containing compound, such as nitrogen oxide, nitrogen dioxide, and ammonia. The second one is sulfur-containing compound, such as sulfur dioxide, sulfur trioxide, and hydrogen sulfide. These kind of compounds are the hazard that are most severe, because these sulfur compounds, such as sulfur dioxide and sulfur trioxide, when they reach rain or water, they will become sulfuric acid, which is extremely acidic and toxic. The third one is hydrocarbons, mostly carbon monoxide and carbon dioxide. The fourth one is halogen compound, such as HCl and HF. They are chlorine and fluorine containing compound. Particulate pollutants are defined by their sizes. For example, total suspended particulates, or TSP, is less than 100 microns, and PM10 is less than 10 microns, and PM12.5 is less than 2.5 microns, and this PM0.1 is less than 0.1 microns. This is a diagram showing that particulate matter or particulate pollution can come from wood burning, about 35%, and auto and trucks, about 21%. Can also come from forest fires, about 13%, and all the other sources, about 30%. Particulate matter can come from direct release of particles, or it can come from the reaction with sun and water vapor to form indirect formation of particles. This slide gives you a common sense on the size of particulate matter. The fine beach sand is about 90 microns in average diameter. The human hair is about 70 microns. And you can see PM10 is about this size, and PM2.5 is about this size. This is the size of different materials from large to small. Raindrop, and then pollen, dust, sea salt, and then bacteria, virus. Combustion product can range from 10 to 0.1. And then these are very small molecules, such as gas and molecular cluster. This is the PM2.5 heat map in China. Fortunately, we are in Fuzhou. The air is not already polluted here. Pollutants can also be classified as primary pollutant or secondary pollutant. Primary pollutant comes directly from the sources of pollutant. Its physical and chemical properties have not changed. The secondary pollutant is caused by primary pollutant in the atmosphere, and this primary pollutant interact with other substances by chemical reactions. And this can be caused by solar radiation or interact with water vapor, which results in a product with different properties from the primary pollutant. And the secondary pollutant is generally more toxic. This slide shows how primary pollutants becomes the secondary pollutant. Primary pollutant such as sulfur dioxide, hydrogen sulfide, carbon monoxide, carbon dioxide, particulate matter, and hydrocarbon can interact with other chemicals by chemical reactions, or it can be caused by solar radiations to undergo photochemical reactions. So these reactions will change their property to become the secondary pollutant. Many factors can affect the concentration of pollutants in the atmosphere. For example, emission. The more it's emitted, the more polluted it is. Pollutant emission is the most basic factor that determines the degree of air pollution. And the second factor is distance. The farther you are away from the emitted point, the less polluted it becomes. So the distance is also another very important factor. Meteorological factors are also important, such as wind and turbulence. And the second one is a vertical gradient distribution of the temperature stratification, which we'll talk about in the next slide. This is also very important. And of course, pressure and humidity also play a role. This slide shows why temperature stratification is important to dissipate air pollution. In winter, you have the winter sun, which is low in the sky and supplies less warmth to the Earth's surface. Now the warm air is acting as a lid and hold the cold air near the ground. Now we all know that the cold air goes down and warm air goes up, right? So the warm air is here and serving as a lid. So the cold air or the polluted cold air cannot go up. So the pollution from wood fires and cars is trapped by the inversion. And the mountains can also increase the strength of valley inversions. These are some examples showing that the temperature on the ground and in the sky can be an important factor for the pollution to go away. For example, this one, the ground temperature is high, the sky temperature is low, so the cool air in the sky will move down, and the warm air on the ground will move up. So the pollution becomes like this. Now it is also true for the second one here, B, and the pollution is just dissipating with the temperature difference. Now the third one, the ground temperature is low and the sky temperature is high. So you have cool air on the ground and you have hot air in the sky. So the pollution is basically trapped between the zones. Now in D, the ground temperature is low, but then it reaches high on this point, but then it goes down again. So you can say that the cool air is here, and then the cool air again is up in the sky. So the pollution is trapped. It will not go down because the air is cool down on the ground. Now in E, the ground temperature is high, and then it reaches a low at this point, and then it becomes warm again. So the warm air is here serving as a lid, but the cool air is here. So the cool air will move down, and then the warm air from the ground will move up. So then the pollution becomes trapped under this line, because here the temperature becomes warm again. Now the cities are generally hotter than the countryside because of the infrastructures. So what happens then is that you will have this urban heat island effect. So this urban area influences the atmosphere through a number of processes. The first one, the paved surface and the concrete canyons absorb the sun's ray and produce heat. The chemicals emitted by cars or industrial facilities or even trees affecting the sunshine in different ways often trapping the heat and creating more heat. Now the warm air rising from the city, as I point out here, the warm air rising from the city may collide with the warm moist air from the nearby body of water. Now if the wind goes this way, this will release precipitation downwind of the city. And this precipitation can affect winds for hundreds of miles. Now, what happens with pollutants in the air? First, the environment can purify itself. So this means that the pollutants will gradually disappear from the atmosphere in the following ways. First, it can diffuse and sediment. And second, it can happen by oxidation and neutralization processes. And third, the plant can absorb some of the pollutant and thereby purifying the air. Now, for the pollutions that were not purified by the environment, they can move around. This is called shift. They can be transferred further along the downwind direction to other areas, or they can be transferred to the stratosphere or to other environmental media. Now, they can also form the secondary pollution and become the secondary pollutant, either by chemical reaction or by solar radiations that we just talked about.